So in my last video, we went over creep states in memory, putting them in a working state or a non-working state, as well as we created the builder and upgrader roles. And you can see in the server, it's been running for a little while, and managed to get the controller up to level 4. So each additional level allows you to unlock new buildings. So now I've unlocked 20 extensions, a tower, and the storage, which will be really useful for the next couple phases. Anyway, in this video I want to go over something called memory and show how that works. But memory is sort of the persistent data that's stored between game ticks. In the game itself, there's a way to view the memory and edit it. So what we're going to do is actually show off that. You can click on a creep or a structure and actually explore the memory of that creep. So we can see this guy is a harvester, and the move to operation he was executing had a destination of the controller 2828 in room W7N4, and it shows some information about the path it took and things like that. If we go over to the upgraders, I have to catch one actually, but he should be in a non-working state, and then once he's full, he'll switch over to working true. Anyway, so there's one memory type for creeps. We can go ahead and go create another one for the room itself. So I'm going to make a new watch list, and currently rooms is undefined. Well, let's go back over to the IDE and make some changes here. So what I want to do is sort of set this up to create some spawn logic. So what we're going to do is this. So underscore dot is Lodash, which is this guy right here. Lodash is a bunch of JavaScript functions for array manipulation and looping through objects, things like that. But we're going to be using one of these called for each. So if I do a quick search, what for each does is loops over a object or an array and executes a function passing each value of that array into it. So I'm going to use this for the spawn logic. So for each, we're going to go back over to the documentation, and we're going to find the game.rooms object. So here's the guy. But within game, there's an object called rooms. Has strings of the room name followed by the room. So for each game.rooms function room name. So that's the logic. We have this hash, and it's going to pass the room name. And then for each of these, let room equal game.rooms room name. If room and room.controller and room.controller.level. Actually, we're going to do owner.username equals. So going back to the documentation here, structure controller, owner. Oh, here's another property, my. It's a Boolean, whether it's your own structure. That's perfect. So we'll do controller.my and get rid of this other guy. So if we're going to loop through the game.rooms and get the room object, and then if there's a room object and that room has a controller and the controller is yours, we're going to execute some code. And this code is going to be this right here. Um, let So here's a Lodash function. It's going to filter game.creeps by its memory role. But I'm going to use a different function here. Let harvester target equals underscore get. We're going to go back over here to Lodash and so I like using this because if the object doesn't have the next node, then it will just return the default value, which can be defined here at the end. So what I'm going to do is I'm going to create this function that for each room, it's going to go ahead and pull some targets for how many of each unit I'd like to have. So harvester target, we're going to do get game room.memory. So if you go over to the documentation here, room itself has a memory object, and it's a shorthand for memory.rooms room.name. And then we can put values in there. So get room memory creep. We're going to call it the census. And then we're going to put a default value of 2. And then if it's going to tally up all the creeps here, so what this is going to do, it's going to be in memory. It's going to pull from the object census the value for harvester. If it doesn't find a value there, it will return undefined and use the default value of 2. And then here, if harvesters.length, so the number of harvesters in that room is less than harvester target, then it's going to go ahead and spawn one. So I'm going to do something very similar up here for upgraders as well. Go ahead and save that guy. So there shouldn't be any changes right now to this. But if we go over to rooms now, and we'd make change the type of rooms, do it a different way, game.rooms. So you can either set it as an object from that screen I was just on, or you can do this, memory.rooms equals that, and then rooms W7 and 4 is this room. You can see that up here in the top right. I'm going to make that an object as well. So now if you reload this rooms object, yep, it's going to have an object W7 and 4. And we're going to append to that census, and we're going to change that type as well to an object. And we're going to append to this harvester. Actually, let's do upgrader. And then we're going to make the target 4. And I'm going to save that guy. And now, if I did this right, it will pull from the room its census value. I'm going to run this command from console and see what the output is. game.rooms w7n4 dot memory returns 4. Okay, so something's wrong with the loop here. We're gonna do console log room room name. Let's see what that gives. Undefined. So the room object's undefined, so I didn't do this part right here. It's gonna be under this game rooms. Hash containing all the rooms available to you with your room names as hash keys. This actually is probably going to be room objects because we're passing it that. So function room cannot read property my of undefined, but it is passing the room object. So let's go back over to the code. Spelled controller wrong. Oh, there it is, spawning an upgrader. And this will wait till it has 300 again, and spawn a second. And it will keep doing that until we have our target of 4. Anyway, that's how you can build a simple spawn sort of logic right here and use a memory to dynamically set your target values. In the next video, we're going to keep building off of this and make it a little more complex, and also add in some logic to search for structures that need to be built by the builders, and have the builders automatically spawn and then take care of those. Anyway, see you in the next video.